Hello everybody and welcome to Jay Saunders' channel. This is Jeffrey. I'll bet you didn't know that right now you're traveling at over, or at least around 2 million miles per hour. And I'm going to show you here real quick just how you're doing that. So what is our speed through the universe? It's actually not hard to figure out. By the day, a point on the equator of the Earth moves at 1,000 miles per hour. By the year, Earth orbits the Sun at 66,000 miles per hour. Our solar system itself, relative to the local standard of rest, our solar system is moving at about 43,000 miles an hour in the direction of the bright star Vega in the constellation Lyra. So let's go over there to the solar system scope here, and here's our solar system in solar system scope, and we are headed towards Lyra. That's up here, so we're kind of sideways, and that's where we're going right there. Go straight into the picture and we're going to the constellation Lyra. But there's more. Our solar system is orbiting the galaxy. It takes our sun, which is our solar system, approximately 225 million years to make the trip around our galaxy. We're in one of the spiral arms towards the outside, and we have been around the galaxy 20 times. Our solar system has to move 483,000 miles per hour but we are leaving the galaxy at an angle to the galactic plane. The galaxy itself is moving through the universe at 1.3 million miles per hour as a result of the Big Bang, and we are moving roughly in the direction on the sky by the constellations Leo and Virgo. So here's the math. You just add them up. The galaxy itself, 1.3 million miles per hour. Seems pretty fast for a galaxy, but I guess not really. So the total here is 1,893,000 miles per hour plus your earthly travel speed, whatever you're traveling. Depends on what direction you're going to and where you are. So back on the scope, it's easier to show you a couple of things here. On the scope is, as things are orbiting and traveling through the universe at the same time, it really actually depends on where you are in the orbit. Because if you're going this way, let's say this whole solar system is going this way, or let's call this the galaxy, it's going, towards the elliptical plane of this thing. If you're on this side going in that direction, you're going faster. If you're coming back like Venus is here, you're actually going slower relatively. So you have the galaxy is moving, but it's also rotating. You could be on the rotating spiral arm that is on this side over here, so you'd be going away from the direction of the travel of the galaxy. So technically, if our solar system wasn't, our ecliptic plane wasn't laying on its side, you could add up the 66,000 and the 43,000 to get you at about 100,000 miles an hour. So you know it's going to be more than 43,000 or 66,000 miles an hour, or 43,000, depending on how you look at it. So if you were just an asteroid sitting out here not moving, and somehow you got to where you were stationary relative to the point of the Big Bang, that would make you stationary. And you could actually watch this solar system fly past you while everything is circling around everything else, and this is circling in the galaxy. So how would you know how, if you wanted to go the speed of light, how would you know? With all these different things going on, how would you really know exactly when you were going to the speed of light? You wouldn't. It'd be just too hard to figure it out. I don't even think a quantum computer could figure it out, because it's all based on data, and we just don't have the data. Another thing to think about is if an asteroid came up from behind Earth as we were traveling through the galaxy, and we bring this the other way because we're going in that direction. So if an asteroid came from you towards Earth right now, towards the screen, from this direction, the asteroid would actually be going slower. But if it hit it from this side, it'd be apparently going faster. And I guess they do the speed relative to the asteroid and us, but we are actually flying through space. So if there's an asteroid just sitting there, depends on how this thing goes through, it really makes a difference how the speed of that asteroid, how it's going to hit us. So anyway, stuff to think about for your 4th of July. So if you did want to go the speed of light, I really don't think you could actually figure it out. And it would probably be critical to know exactly when you're going the speed of light. But you know, if you think about it, the speed of light really just doesn't work for travel. It's too slow. If it takes 1,500 light years to get to the nearest galaxy or whatever, or wherever there is one, you don't have 1,500 years. Nobody does. Even if it's 10 years. How are you going to build a spaceship that's going to last 10 years? It can't even build a car that doesn't break down. So you'd be stuck out there with a, bad condenser or something, who knows what. So that's just not going to work. And if there's an object and you're going almost at the speed of light, and you hit an object out there, that object is going to go right through you, and you're going to be history. So light travel simply doesn't work, and that's why the only way that these, and I'll just go ahead and call them aliens or ETs or whatever, and maybe us eventually, the only way that we're going to be able to travel through the universe is through some kind of interdimensional time warps. Face it, it's the only way. So I hope that was fun facts there. So, have a great 4th of July and watch your backsides. See you in the next video.